Hey guys, welcome back to the shop. I got you here in the office at our granite surface plate, and I am working on another comparative measurement job right here. As I began working on this and getting it set up, I thought it would be great to go ahead and fire up the camera, bring you guys along for the ride, show you what I'm doing and why we're doing this, and some of the tools that we're going to be using for this inspection here. So what I am beginning to work on is the final milling setup for the hardtail vise that is going to be the dynamic jaw body. Now, I've already machined all four sides of that body, but as I showed in previous videos, I left two of the sides that's going to be machined to a 3-inch width. I left those oversized because I wanted to do that. I wanted to finish that in our Milltronic CNC mill. In order to do that, there's a couple different ways you can obviously set up. The easiest way to set it up is to use some machine vices like this right here, okay? So that was my plan. I want to get 2 mill vices set up in the mill table, get them trammed in nice and straight, and then we can set that jaw down into these 2 mill vices, clamp it, do our face milling, flip the part over, clamp it, do our face milling, and with any luck, we're going to hopefully be on size. But before I began that job, I haven't started it yet. I wanted to start with this right here. I wanted to go ahead and measure the bed height of 2 of my vices here. Now I've got a few of these Tico vices, and I did not purchase any of these as a matched pair. They were not ground to be a matched set in any kind of way. They were all just purchased individually and shipped individually. Now saying that, they do have a specification that they grind these things to, which is typically a 2 7/8 bed height on the surface of the bed there, okay? So I wanted to go ahead and take 2 of them and do a comparative measurement and see just how close they are, how closely matched they are on the bed height. I know that they were going to be pretty darn close, and with the first inspection of our height gauge, I was getting less than 1/1000th variation between the two. Now that was out there on the machine, so I knew that's not going to be accurate enough. We need to get it in here on the granite plate and do some inspections to see exactly what it is that we're reading. All right, and so that's what we're going to do. We'll go ahead and start off with our height gauge here. We'll show you how I use that to you can use this to measure what that height is. But then after this, we pulled out our tense indicators, and then now we can start doing our comparative measurements. But we can also, what we're going to be inspecting for is flatness and parallelism across the bed of the vise right here. And that's what these 2 gauges right here are going to be able to tell us, is just how flat that surface is, and if one of these vices is higher than the other. I'm going to show you the workpiece that we're going to be setting in there so you guys understand what it is that we're going to be clamping, and then we'll go ahead and start our comparative measurements here. So just to recap, this is going to be the dynamic jaw for the hardtail vise build. That guy right there, all right? And what I'm wanting to do is get in our Milltronics and finish milling this surface and then the opposite surface 180 degrees out. So I want to be able to get this thing set down in a couple of mill vices, and I want to make sure that we are parallel to the surface of our mill table there. This is right at 20 1/4 inches right there, so you got a pretty good area that you have to span to be able to clamp. So once we get our vices set up, we'll be able to have a vise right here holding this in and another vise down there, and that is going to be a nice solid rigid setup to begin our final face milling of that dynamic jaw body. So the first tool that we'll use is our digital height gauge here. I absolutely love this tool. Ever since I got this, I found myself using it more and more. I love using it over the vernier style because you have a direct reading right there. You have the ability to set a 0 on any surface that you want and then be able to do a measurement like we've shown a few times during this hardtail project right here. So we'll use this to go ahead and get an initial measurement. And what you have to keep in mind, this particular digital height gauge has an accuracy of 1/1000th. So you can take a measurement with this knowing that you're going to be within 1/1000th, but sometimes you want to measure a little bit finer than that, and that's where we have to pull out our indicators. So we'll go ahead and it'll turn on as soon as you start moving it. See right there? So what we'll do is, just to begin, I've already got the surface plate nice and clean before we started this job, and it is ready to go. We'll go ahead and just bring this guy down and make sure that we're still on a 0. And we are 0, 0. All right. So let's see what we're measuring right here. Bring this guy in and just touch it anywhere you want to on this vise and see what we get. Got to be gentle with it though. You don't want to come down and touch it hard. You just want to put just enough pressure to move it until it stops. All right, so 2.8755. I did this a few times and I was getting 2.875 to 2.8755. So it depends on what your tolerance is. You're going to be, okay, that's good enough. A lot of times when we use this, we're measuring thousandths. We're not measuring a half a thousandths. In this case, we're actually measuring under a half a thousandths, and that's why we wanted to pull out our indicators and do some comparative measurement. But what this is doing, though, is this is actually telling us that these mill vices are machined to a 2 7/8 bed height. We'll go ahead and do that again. Let's see if we get the same reading. We do, 875.5. Let's come over here to our other vise and do the same measurement. All right, come in here and let's take the same measurement there. 875.5. So I got the same exact reading this time that I did on the other side. You see it just changed, 875. And after doing this a few times on both sides of the vise there, that's what was happening. I was getting a half a thousandths variation. So what that's telling me is that this is somewhere between 2.875 and 2.876 according to the height gauge. So if you're wanting to kind of split that 1/1000th difference, that's where we need to get our test indicators out and see exactly where our height is stacking up. The other thing that you can do with this height gauge is, if you want to use a dial indicator or a dial test indicator, you can take the scriber off and you have some other attachments just like this you can clamp on there, and you can actually set up a dial indicator, bring it down to your surface plate and get a 0 set on your dial indicator, 0 your height gauge out, and then bring it up and do the same measurement and bring it down until your dial indicator reads 0, and that'll give you a reading there as well. Okay, but again, you're working on this guy as a half a thousandth, so that's where, if you're using a dial indicator, you can use this to kind of take that exact measurement that you want to down to the exact tenth. So we know we're 2 7/8 using our height gauge. Let's go ahead and switch over to our test indicators, our dial indicator and our dial test indicator, and we want to do a comparative measurement on both of these mill vices to see where this height stacks up at. Okay, here's our 2 measurement tools that we're going to be using to take this comparative measurement with. Now, we do have a bit of redundancy going on right here. You do not need 2 of these tools set up to do this measurement. You only need 1. But I've got both of them out because I enjoy all of these tools. I like using them. And I thought it'd be a great way to compare a couple different types of inspection holders, surface gauge, things like that you can use to do these kind of measurements. So this guy right here, this is a number 257 surface gauge made by Starrett. This is a very common tool. It's not very expensive. You can find these guys on the used marketplace. You can find them in antique shops. You can find them used, places like that. So it's a very affordable tool that I think most people that's doing machine work and this kind of stuff, they usually have a surface gauge. You just got to make sure you have the right clamps and snugs and adapters to be able to hold your indicators the way you want there, okay? You have a fine adjust on there, and this thing can pivot and move anywhere you want, and it's a very useful tool, all right? Now this guy right here, this is another inspection holder right here that is kind of a universal setup that was made by Solid Rock Machine Shop. It's a custom made to order application, and it's a very, very high quality tool that I love using for this kind of measurement right here. It's got a Noga arm on there, and I've got a tenth indicator attached to it, and you also have a fine adjust there as well. Now I've got these guys already set, so I'm trying not to move them, but I just wanted to kind of show you the two different tools that we can use here for this measurement, all right? So we'll start with our surface gauge right here, because this is kind of one of the more common uses, and keep in mind you can use your height gauge for this as well. I like the height gauge also because it has a little bit larger, heavier base there, just providing a little bit more stability. So our surface gauge should be set, and we're going to come in here and I'm going to show you guys this, and I'll make sure that I get you guys a nice tight shot of these indicators so you can see that needle movement up close and personal. But for now, we'll just go ahead and kind of start with our overall wide shot. And what we are doing, I'm going to start with this vise right here, and I have got our indicators set to a 0, or as near a 0 as you can, because whenever you're trying to adjust these tense indicators with these little dials right here, these little screws, it's extremely fidgety. And any time that you just basically touch it, if you touch it up here, it moves that. If you try to turn that dial face to line it up on the needle, it moves out of place. So you just got to kind of get it as close as you can. You got to get in here and sweep it a little bit. You can see that needle moving around, and try to get as close to 0 as you can. If you can't get it to 0, you just make a note of where your measurement starts on. If it's on a different line past 0, make a note of that, and then work from there. This one's going to be pretty close. We've still got it set to a 0, and you can see how we're taking it and we're sweeping across the width of that vise body right there, that base. And I can see a little bit of movement in there. What this is telling me, what I'm doing right here is that I'm actually inspecting for flatness, okay, or parallelism. And I can see a little bit of movement as we go across from one side of that to the other. Right there, it drops off 1/10. Okay, we can come up here. I can see that needle coming back up to 0. There's a plus 1/10 right there. All right, so we've got a little bit of variation in our flatness. Right there, it drops off, and right here, it rises up. So that has to do with the tolerance on the machine whenever these were being ground. Okay, that is not throwing this vise out of spec or anything like that. All these things are always machined within a tolerance. If I had to guess, they probably have a 1/2 thousandths tolerance whenever they manufacture these guys. But what we want to do is just kind of check for a comparative height between this vise and the vise over here. So let's just, for video purposes, let's call this 0, but we'll also bring it around here to the other side. And let's check this side also. All right, once you get it on there, you kind of get it settled out a little bit. Okay. So I'm getting that's a half a division, should I say, not a 1/2 thou or 1/2 tenth, but just a 1/2 division. So it looks like we're pretty consistently lined up on 1/2 tenth to 1/10 on this side right there. But like I said, for video purposes, let's call that 0, because I've already set these guys to kind of speed up this operation, because it takes a while to get that thing set to a 0. You can see right along this outer edge that it drops off about 2/10 there. That's going to give us a 0 set for this. Now let's go ahead and move over to our other vise and compare that reading. All right, we're going to sweep this vise now and do a comparative measurement on the difference in height between the two. So this guy is measuring just a bit higher. On the dial test indicator, just in that spot right there, we're 2.5 higher than the other vise. As we sweep it across, I'm just checking it. We have a spot right there that's 0.3 higher. You have a little bit of a drop off closer to the edge. To a little bit higher, right in the very middle of it, just slightly. It looks like our highest point on this side right there is 0.3. Okay, let's go ahead and check the other side and see if it matches it. So it looks like we're about 0.3 higher on this vise. All right, so let me get over here a little bit easier. So it looks like it's the same. I'm getting 0.3 right there. You can certainly, whenever you do an inspection like that, see how I just bumped it right there? I wasn't paying attention. I bumped it. I think we're still good on that. It just kind of moved it a little bit, but yeah, we're good. So 0.3. There's your 0.3 right there. So it looks like right about here, sort of the main area that we use the vise in is about 0.3 higher than our other vise, okay? There's one of your high spots there, about 2.5. A little over 0.2 in that area there. As we sweep that indicator across that face, you can see the highs and lows. Actually kind of drops off as you get close to the edge there. So we've already established our reading of what we were wanting to take right here, and that was our comparative measurements, wanting to compare the height of one vise versus the height of the other. And we just showed that in setting an indicator over here to a 0, coming over here and inspecting it with that same 0 set and showing a 0.3 height difference between the two. So one might ask, well, is that close enough? Is that considered accurate? I would say absolutely yes. That's well within the tolerance that we're looking for the machine work that we're after here. We're using a milling machine, a CNC machine, and you got two vices that are less than a 0.5 thousandths difference in elevation right there. And of course, that's going to cause a little bit of error in your machining, but I firmly believe that if you're looking for, let's just use our part for example. We've got that nice boxy section that we're going to be machining. If you need it to be less than a half a thousandth square and parallel, then you need to be going over to a surface grinder to finish that guy out. But that's not the tolerances that we're looking for. In fact, if I don't have the print with me, but I believe we have a 3 thousandths tolerance on the dimension of that area that we're going to be machining on there. But the fact is that I wanted to just be sure that 2 of these vices that I have are on the same elevation, and that's all I wanted to do here is check that and bring you guys along and show you some of that. So we already used our surface gauge comparative tool right there, and I didn't show you this one yet, but this was the other indicator base that we had set up, and I've got this dial indicator, tense indicator set up on that, and I had it set to a 0.2. I don't know if it's moved or not, but yep, so we still got a good 0 on this guy right here too. Let me give you guys a quick little shot of using this one as well. All right, here's a closer look using our dial indicator with our solid rock indicator base here. I like this setup just because it's a little more stable with the weight of the base here as you move it around and slide it. So this is just a nice tool to use because of it being a little bit more of a universal setup. You got a heavier base. It's just a little bit more stable than the surface gauge itself. But they're both going to give you the same output, the same readings, you know, as long as you're careful on how you're using them, okay? But this really is a nice indicator base that Steve Barton makes over at Solid Rock Machine. You got a bit of a universal application with different hole locations, so you have different reach. You can actually set this up to use as a squareness comparator as well, because he's got this foot machined and ground that's on the front there. It's got that radius so that you can set up an indicator and use this as a squareness comparator there as well. We've got a previous video using a Taft-Pierce squareness comparator, but you can use this for the same job. But also the difference here is, of course, our dial indicator that we're using. I really like using dial indicators, and I think that they're a little bit easier to use and show on videos there as well. So I just wanted to set this up to show the difference between the two. That's still set to a 0 there because I had set this one before we started. So we'll go ahead and let's come over to our other vise and let's see if we're getting the 3/10 difference on the dial indicator that we were getting on our test indicator. All right, we'll come in here and check this guy there as well. Getting 2/10 there. All right, there was a high spot right there. There's 2, so I'm getting about 2.5. About 2.5 right there on the dial. So an approximately 2.5 difference. This particular setup with the dial indicator does seem to be a little more stable, you know, according to the needle. It's not quite as jumpy moving around, but I feel confident that we're getting the same reading there. But I'm getting I'm going to call that I'm getting a 0.5 difference between these two, but it doesn't matter. You're not comparing these two on what you're reading. I was just showing a difference in a setup. You can use a surface gauge with a test indicator, or you could use a guy like this to get the same exact measurement there. Since we're working on comparative measurements, let me show you this here as well. Say you wanted to accurately measure what this height was, as in measure the dimension so that you have a number written down and you know exactly what this is from the 0 point of our surface plate up to this surface here that you ground. You can take a stack up of gauge blocks. Here I have a stack up of exactly 2.875. You get your gauge block stack up Then you get your dial indicator set to a 0 on this set of gauge blocks right there, okay? It's not perfectly on 0, but it's darn close. I told you it's really tough trying to get that thing set and stayed on a 0 there. But let's just call that 0 for video purposes. So we know that that height on that 0 is exactly as close as I can get on these gauge blocks here, 2.875 inches. You can then take your indicator and bring it right over here to your workpiece. And now you can do another comparative measurement to see where your height difference is. Let's come in here and sweep that. So it looks like we're getting, let me move my gauge blocks a little bit over. So it looks like 3/10 there on the test indicator. Now I wrote this down just as an example. Let's say that you were machining a part or grinding a part to 2.875 inches. And this is your tolerance, plus 1/2 thousandths minus 1/2 thousandths. So that actually gives you a 1/1000th tolerance to fall within. Usually you're trying to shoot for your target size right there. All right, in our case, we hit within our tolerance because that test indicator is measuring plus 3/10, plus 0.0003. All right, so landed within our tolerance right there. So that is just another way that you can do a comparative measurement there with gauge block stack up like we did right here. This is also another great example of a setup for inspections when you're pulling parts directly off of the machine and you want to measure them, inspect them to make sure they're within the tolerance. So you can have a small surface plate set up near your machine on your toolbox, and you have a test indicator like this set up, and you use your gauge block stack set up to get your indicator set to a 0 point. And then once you have that, this is set and ready to go. And at that point, you're simply taking your parts off the machine, and then you're simply sweeping them underneath the indicator to check to see if they're within the tolerance that you're set for. Okay, so just another example of how you can use your comparative measurements here, how you can use your gauge block stack up to get a known 0 for a measurement that you want, and then using that to inspect your parts to see if you landed within your tolerance that you wanted there. So we don't necessarily have two vices that are absolutely matched height. In order to do that, you'd have to have both of these on a surface grinder and grind those beds so that they do measure the exact same. And you can order vices that way too. A lot of guys do that, especially if you're going to be using it for highly accurate work. But in our case, we're measuring right here for video purposes. Let's just call it 3/10 difference in height. That is going to be perfectly suitable for our machine work that we're going to be doing out on the mill. So nothing wrong with what we're measuring right here. I'm actually really happy with the measurements that we had, because I was worried going into this before I ever inspected any of these guys that it may have been a thou or even more than that off on different height there. And I was really hoping that we were going to be where we are, let's just say under that 1/1000th height there in difference on our two mill vices. So we got two good vices here. I'm going to take these guys out to the mill and start that setup. That's going to be a separate video, so I hope you come back and check that out. I had fun getting my tools out and sharing the uses of these guys with you, and hopefully continuing to help all the people out there that's trying to learn the trades, learning machine work, precision inspection work, how to use your granite surface plate, how to use these indicators for comparative measurements, and all those things like that. I really enjoy doing this. This is fun for me, and I like getting the camera out and sharing it with you. All right, so we're gonna wrap this up. It's all for today, and I hope to see you out there on the shop as we finish out our hardtail vise.